Okay, so in this question, there's no diagram given to us to begin with, which actually makes sure that we are modeling fully exactly what's happening. So we'll start with a good sketch. So in the question, we are told that the particle is projected from level ground and it comes back and hits the ground. So I'll just model it with this. Here's the initial velocity, and we're told that the angle that that initial velocity acts at is alpha. The maximum displacement that the particle reaches, or the maximum height the particle gets to, is 42 meters. And we're told that when it does land, it lands 196 meters away. All right, so this is all of the information that we're given, chosen upwards to be my positive direction. So let's get into it. Resolving vertically, I'm just going to fill in all of my SUVAT variables. I know that that maximum point is 42 meters up from where I've started. The initial velocity is going to be u sine alpha. And the final velocity, the importance of taking this midpoint or this maximum point is the velocity there is actually going to be 0. Okay, acceleration negative 9.8. And we don't know the time that it's going to take. Okay, why is that useful? Because I can calculate what the initial velocity should have been. So v squared equals u squared plus 2as. Filling in my variables. And rearranging to make u sine alpha the subject, I get 29 to two significant figures. All right, u sine alpha equals 29. I'm going to now resolve horizontally. Filling in my SUVAT variables. Horizontal displacement is 196. Initial horizontal is u cosine alpha. The final horizontal velocity is u cosine alpha as well. There's no acceleration, hence the initial and final velocities being the same. And the time taken, we don't quite know yet. If we go back to the vertical resolution, we can calculate the time that it would take to reach that maximum point. We've got enough variables. So we'll go ahead with s equals half u plus vt. How long would it take for a displacement of 42 meters? Rearranging, t equals 2.9 seconds. So if it takes 2.9 seconds to get to the maximum point, it will take another 2.9 seconds for the particle to get back down to the ground. And we'll use 5.8 for our time variable. All right, so from there, should be quite straightforward now for us to find out what that horizontal component is. 196 equals u cosine alpha multiplied by 5.8. Rearranging, u cosine alpha 34 to two significant figures. Okay, we were out to find alpha and to find the value for u. Well, we've got u sine alpha and we've got u cosine alpha. Instantly, I start to think, how can I combine them into tan? And just dividing one by the other, I should get an expression for tan alpha. 29 over 34. Inverse tan gives me my answer for alpha. and alpha will equal 41 degrees to two significant figures. So if I found alpha, I should be able to substitute that into one of the previous expressions and find u. We'll sub it into u cosine alpha equals 34, which rearranges to give me u equals 34 divided by the cosine of 41 into the calculator, leads us to an answer of 45. Okay, so alpha equals 41 and u equals 45.